Hello student, welcome to my channel Learn More Maths by Vara Kumar. Today we are going to solve some problems from the chapter Progressions Exercise 6.3. Third problem, these problems are related to the formula sum of the n terms of an arithmetic progression Sn. So see student, what he has given. Third one, in an AP there are some bits in the third problem. This is first bit. So one by one we have to solve. So first bit, given a is equal to 5, d is equal to 3, an is equal to 50, find n and Sn. So before that, a student, you must have clear idea about the formulas in an arithmetic progression. Just simply we have two formulas, nth term an and the sum of the n terms Sn. So and the letters involved in the formula you have to learn. So we have to learn first nth term of an arithmetic progression, nth term of an AP. So student, it is denoted by an. So an is equal to a plus n minus 1 into d. So nth term of an AP, an is equal to a plus n minus 1 into d. So in this you have to learn what are the letters involved in the formula. You must have very clear idea. So here an is nth term, or here n denotes number of terms. So n is equal to. So a is the first term, student. A is the first term. And d is the common difference. Okay. So nth term an is equal to a plus n minus 1 into d. N is number of terms and a is the first term, d is the common difference. Suppose if I want to find a third term, it becomes a3. Third term can be written as a3, student. A3 is equal to, we know, a plus 2d. Suppose if I want to find a 10th term is equal to, it can be denoted by a10, it is a plus 9d. So if I want to find the 100th term, it can be written as a100, student. A100 is equal to a plus 99d. So you must have clear idea about the terms. So one more, we have sum of the n terms of an arithmetic progression. Next, one more formula, sum of the n terms. Sum of the n terms of an AP of an arithmetic progression. So we have two formulas, student. First one, Sn is equal to n by 2 into 2a plus n minus 1 into d. Sn is equal to n by 2 into 2a plus n minus 1 into d. Sum of the sum of the n terms of an AP, Sn is equal to n by 2 into 2a plus n minus 1 into d. So when we know a, n and d values, if we know a, n and d values, we have to use. If we know a, n and d values. So if we know a, n and d values, we have to use this formula, student. So second one, we have one more, Sn is equal to n by 2 into a plus l. So if we know a and l values, we have to use this formula. If we know l value, if we know a comma l values, we have to use this formula. That you have to remember, student. In these two, just you have to see what is n. So n is a number of terms in both the formulas. N is a number of terms. So a is the first term. Sometimes a1 is also a1 is equal to a, it is the first term, student. A is the first term, and D is the common difference, same, D is the common difference, and L is the last term, L is the last term. So sometimes it is also known as nth term and last term, both are same student, don't confuse with the A and L. Sometimes we write Sn is equal to n by 2 into A plus L, and sometimes we write Sn is equal to n by 2 into A plus An. So these are the terms involved in the formula. Suppose if he has to find the sum of the first 5 terms, so sum of the first 5 terms is denoted by S5, sum of the first 5 terms, sum of the first 5 terms, it is denoted by S5. Suppose S10, what it is? Sum of the first 10 terms, student, sum of the first 10 terms. S20 is what? Sum of the first 20 terms. So student, before going to solve the problems in third one, you have to remember the formulas and the letters involved in the formulas, then you can do very easily, you can solve very easily third problem. So these formulas you have to remember, student, before going to solve the third problems. So here he gives A value, D value, he has given A, D, A, N. He is asking to find as N and Sn. If you know the formulas are clear, you can find very easily. So now we have to, so see student, now we have to solve this problem. So what he has given in an arithmetic progression, in an AP, given A is equal to 5, D is equal to 3, An is equal to 50, find N and Sn. So see student, how can we find? So first what he has given, student, A is equal to 5, comma D is equal to 3 has given, and An is equal to 50, and An is equal to 50. So in an arithmetic progression, An can be written as A plus n minus 1 into D. An can be written as A plus n minus 1 into D is equal to 50. So now we have A and D values, just substitute here, we can get n value. So substituting, student, now I am substituting A is equal to 5 plus we have to find the value of n, D is equal to 3 is equal to 50. So now take 5 to the right side, so it becomes minus 5, 3 into n minus 1 is equal to, so 50 minus 5, which is 45. So plus 5 becomes minus 5. So now take 3 to the right side, n minus 1 is equal to 45 divided by 5. So 5 ones and 5 nines are 45. Therefore n is equal to, take minus 1 to the right side, it becomes plus 1. It is 9 plus 1, that is 10, student. N is equal to 10. So n value, we got n value. And again he is asking to find as Sn. So sum of the Sn, we have Sn is equal to n by 2 into, student, here we don't know the last value, last term. So yes, these two are the first and last. We can use Sn is equal to n by 2 into A plus L or A plus An. So suppose we have to use n by 2 into 2A plus n minus 1 into D. Sn is equal to n by 2 into 2A plus n minus 1 into D, student. So here this is the first formula. When we know the A, N and D values, or we have to use Sn is equal to n by 2 into A plus An. If we know the A and N values, we have to use this formula. So we have N and An values. N is equal to 10, student, and n by 2, that is 10 by 2 into A value is how much? 5 plus An is 50, student. An is equal to 50. So 2 ones and 2 5s, 5 into 5 plus 50 is 55, student. Just we have to multiply 5 into 55. 5 5s are 25, 2 5 5s are 25, 2 plus 27. So it is a 275. Therefore n is equal to 10 and Sn is equal to 275. So n is equal to 10 and Sn is equal to 275. So like this we can find. Hello student, see this is second bit from third problem. So what he has given, see given a is equal to 7, a13 equal to 35, find d and s13. So see student, how can we solve? So what he has given, I am writing a is equal to 7 he has given and a13 is equal to 35 he has given student. a13 is equal to 35. So these two things he has given to us student. a13 in an AP, a13 can be written as a plus 12d is equal to 35. a13 can be written as a plus 12d, but he has given a equal to 7. Substitute here, that is I am substituting 7 plus 12d is equal to 35. Take 7 to the right side, we have 12d is equal to 35 minus 7, which is 28 student. D is equal to how much? 28. D is equal to 35 minus 7, which is equal to 28, 12d. So take 12 to 35 minus 7 is 28 student. Take 12 to the right side, we get D is equal to 28 divided by 12. 28 divided by 12. So now cancel by 2 6 are 2 14s. Again 2 3s are 6, 2 7s are 14. It is 7 by 3 student. 7 by 3. So D is equal to 7 by 3. So he's what we have to find? D and S13. Therefore we have D is equal to 7 by 3. So next we have to find S13 student. S13, for that we have Sn is equal to n by 2 into 2a plus n minus 1 into d. So student, here we don't know the last term, just we have to use the first formula. So we have n value, a value and d value. So n is equal to 13 student, we have to find S13 is equal to n by 2, that is 13 divided by 2, 2a, 2 into 7, a value is 7, 2 into 7 plus n minus 1, that is 13 minus 1 into d is equal to 7 by 3, d is equal to 7 by 3. Just I have substituted all the values in the formula student, n by 2. So here S13, n is equal to 13, n by 2 is 13 by 2, 2a, that is 2 into 7 plus n minus 1, that is 13 minus 1 into d into 7 by 3. So here we have to simplify student. S13 is equal to 13 divided by 2 into 2 into 7 is 14 plus 13 minus 1 is 12. So 12 into 7 by 3. So 3 1s and 3 4s are 12 student. We can cancel here. We get 13 divided by 2 into 14 plus 4 into 7 is 28. 4 7s are 28. Again we have 13 by 2 into 14 plus 28 is 42 student. Here we cancel 2 1s and 2 2s, 2 1s. So 13 into 21. 13 1s are 13 student, write 3. 13 2s are 26 plus 1, 27. So 273. So S13 is equal to 273. Finally, therefore we have D is equal to 7 by 3 and S13 is equal to 273. So these three values he is asking to find us in the second one student. So this is the second problem student. So one more so in third problem, third bit student, one more third bit, given A12 is equal to 37, D is equal to 3, find A and S12. He is asking to find the A and S12 student. So in an arithmetic progression, A12 he has given. So A12 is equal to 37 he has given student. but in an AP, A12 can be written as A plus 11D. A plus 11D is equal to 37. So here E has given D is equal to 3, just to substitute the D value, student. That is A plus 11 into D is equal to 3 has given, I am writing 3 is equal to 37 since D is equal to 3. So from this we can get 11 into 3 is 33, A plus 33 is 37, just take 33 to the right side, we get A is equal to 37 minus 33, that is 4. Therefore we have A is equal to 4. A is equal to 4, student. So next we have to, he is asking to find us S12. S12. So we have Sn is equal to, Sn is equal to n by 2 into 2a plus n minus 1 into d. So this is the first formula, student. When we know a, n and d values, we have to use the first formula. We don't know the last term. So see, student, here we have S12 is asking, that is n is equal to 12. That is 12 by 2 into 2a. 2 into a value is 4, student. 2 into 4 plus n minus 1. N is again 12 minus 1 into d value is 3 has given. D is equal to 3. So by cancelling 2 ones and 2 6 are 12. So 6 into 2 into 4 is 8 plus 12 minus 1 is 11. 11 into 3. 11 into 3. So student, 6 into 8 plus 11 into 3 is 33. So 6 into 8 plus 33 is 41, student. We have to multiply 6 into 41. 6 into 1 is 6. 6 4s are 24. Therefore S12 is equal to 246. Therefore we have to write A is equal to 4 and S12 is equal to 246. So he is asking to find us the A value, and S12, A is equal to 4 and S12 is equal to 246. So this is the third.